So this is my latest big build. It is an 18,000 watt heater bank. It's a heated wash tank, 720 gallons. And the reason that we did the modification, the tank was here. The only thing I did was design the heater bank and do the controls. I built the control box and the programming. The tank was here. We used to have over the tank heaters right here, but they would keep getting broken by these big ass carts, or the water level would run low and they would burn up. But we have an autofill system, 2 floats tied in series. Turn on some solenoids over there and fill it up. And Sparger air agitation system at the bottom. Recirculation system, that's pre-filter, that's the pump. And the 2 filter canisters over there, you only run one at a time. You switch them out as they get full. This is to protect, the heater, and obviously filter out the stuff that we're washing off. It's important to, since this heater bank is tied in series in the plumbing, from the recirculation filter or recirculation pump through the filters into the heater bank back into the tank. So it goes to the first stage, the big heater first, and the second stage, a small heater, and then into the tank. Once these filters get full, I set an alarm. What I use is this switch. We use pressure differential. There's a switch back there. As the high side, the supply side, reaches 30 psi on the gauge, that's a full filter for me. So the low side, pressure differential, the low side will be putting out about 7.5 psi. And that's when that switch trips, and it'll shut down the recirculation pump, the heater bank, and it'll alarm out up on the control console for the operators, so they know when to switch them over. We use this Keyence sensor. It's transducer, pressure and temperature. It gives me a 4 to 20 milliamp signal that I ran into the box in here. I actually put that into a signal conditioner. Got 4 to 20 milliamp, 0 to 5 volts, and then scaled it down from there. And then there's my process temperature from that point right there. Inside, you got the PLC, signal conditioner, power source, 24 volt power source, contactors, my transducers for my heater current, and I can go in here and monitor my heater current. And I got an alarm set. If one leg drops down below 19, that it'll alarm out, letting us know the heaters are bad. In that event, obviously it would fail open. Typically a heater will short, blow a fuse, we'll have to turn it back on, then it would fail open, and then I would, whoever's working on this would know that the heater's bad and we need to come and replace it. I got the raw data pinned out here, and what else do I got? Control transformer, runs the 120 volt Sparger pump and everything else. I got 120 volt controls, 24 volt controls. I didn't get a pick of everything I wanted. I got handed a bunch of stuff and was told to make do with a lot of it. So this control box isn't laid out exactly how I wanted to lay it out. It's a little cramped, but it got the job done. Let's see. I got my auto run page, manual run page. Everything's black themed. If it's not on, it's not engaged, it's black. I got a God mode. I've already logged in. God mode will let me come in, and for troubleshooting purposes, I can enable each and every output regardless of any interlocks, and that allows me to troubleshoot anything that's going on from the console without hooking up the PLC. I could modify basically everything except for 2 things in the program from the HMI, so that's really nice. Back. But that's the latest build. I programmed the HMI and the PLC top to bottom. That was pretty. This is the first project I've done where I built the control box and did all the programming myself. So I'm really happy with it and the way that it came out. Just wanted to show it off a little bit.